Okay, we're on to question number 4. So here we go. Jake gets a serious bacterial infection. The table shows the number of harmful bacteria in Jake's body during the first 2 hours following the infection. Here's the table. Okay, time in minutes, which is on the bottom of my graph paper, and the number of bacteria, which is up my y-axis on my graph paper. Things first, we need to draw a graph and plot the results. So when they say draw a graph, they're talking about doing the axes. And you'll notice here that I've put in little red dots so that they're equally spaced. Here I've done a red line every 10 squares, and up here I've done a red line every 5 squares. So if I start to put my results, okay, you can see here I've put equally spaced 30, 60, 90, 120, 150. That's what they've written in their table, but that's not how I choose my axis. I choose my axis based on my maximum time, and I need to make sure my maximum time fits on my graph paper. And I also need to make sure that these go up in equal steps. So in this case, my every 10 squares counts for 30 minutes. Okay, there's a real common mistake people make with graphs is that they don't keep these equal, these steps. So 30 minutes for each 10 squares. Okay, along the other side, well, again we'll use the same logic. 64 is my maximum, so I need to go up at least to 64, probably go up to 65. So if I count up, I could put 5, 10, 15, etc. equally spaced again, up to 65. I've done the drawing the graph part. The next thing I need to do is plot my results. So what I'll do is I'll look to see when my time is 0, the number of bacteria is 1. So that would put me a plot there. 0 time, 1 bacteria. The next one, 30 time, 30 minutes, and 3 bacteria, etc. And I would get a lovely set of data points like that. That's my 2 marks. Now that's A part 1. A part 2 says, draw a line of best fit on my graph. So you've already done that if you were keen. So if I pen, what I'm going to do is I'm going to draw a line of best fit, trying to go through or near to as many of the points as possible. So I've done that with a mouse, it's not smooth. You can use a pencil, rub it out and redraw it if you needed to. Nice smooth curve. So that's done for 1 mark if I've drawn it fairly smoothly, which I haven't. Finally, use the data to determine a time interval for the number of bacteria double. That's quite a hard question. However, what we can do is we can do the following. We can pick a number of bacteria, here 10, see the amount of time it takes to have 10 bacteria, which I work out to be about 60, 63, 66, 69, 72 minutes. Okay, 72 minutes. How long would it take to double? Well, let's go see how long it would take to get to 20. Again, draw these construction lines as they're called in. If I was to do that carefully, I would work it out to be about 72 to about 91, 92 minutes, which gives me an answer of about 20 minutes. Now that's what I've learnt on the course, that bacteria take about 20 minutes to double. Okay, and that shows a very similar trend here. Okay, well, the next part, again, part 4 links in with the first 3 parts. Why does this matter to Jake? What's the significance, Jake, of this rate of growth? Okay, there's a couple of answers here. 1, from the graph we can see it gets steep really quickly. There's a fast multiplication. Bacteria reproduce really quickly, and that means that there's going to be more likely of him getting cell damaged or getting sick from the toxins or the pollutants that are made by the bacteria. Which means if they're growing that quickly, he may need to take antibiotics to support his immune system. Okay, carry on a bit further. So part B, the separate bit of the question. When harmful bacteria enter Jake's body, he responds by producing antibodies to destroy those bacteria. He'd not come into contact with this type of bacteria before. Okay, I put that phrase in there for a reason. Okay, the graph shows the number of bacteria and antibodies in Jake's blood over a 24-day period. One line shows the number of bacteria, the other line shows the number of antibodies. So they don't tell you which line's which, but instead they ask you to work it out. So which line, A or B, shows the number of bacteria? Well, if we look to see which line goes up first, this thick line, A, goes up first. The infection grows. As a response, so therefore comes afterwards, a response to the increase in bacteria, the body then produces lots of antibodies. So B will be the number of antibodies, and A is the number of bacteria. Here's the mark scheme. Okay, so you have to say A, and you have to explain your answer as they say so in the mark scheme. So A, because bacteria stimulate antibodies, or once antibodies are produced, then A can go down. Okay, you have to say that A causes antibodies to produce, or you can say that once antibodies are produced, then the number of bacteria will go down. Okay. Part C. So Jake's white blood cells are used to destroy the invader bacteria. How can Jake's white blood cells do this? Put ticks, plural there, in the boxes next to the correct answers. If you've missed it, ticks, plural, in the boxes, plural, next to the correct answers, plural. You're looking for more than one. So the other hint is here, it's out of 2 marks. So how can white blood cells work? Well, they can engulf the bacteria, the large macrophages or phagocytes. Can they stop bacteria entering the body? No. What they can, that's the job of your skin. That's not a white blood cell. Can they cause the bacteria to mutate? No. Can they cause the bacteria to reproduce? Well, that's not great. That means we're going to end up with more bacteria. So that's not correct either. So they don't stop the bacteria entering the body. They don't cause the bacteria to mutate. They don't cause the bacteria to mutate, to reproduce. Okay. Even if you're guessing, do cross out the definitely wrong answers so that you increase your chance of getting it right. Okay. Okay, these large white blood cells engulf, they encompass, they go around the large bacteria, and also they digest them. There's 2. And finally, they also produce antibodies. The smaller white blood cells produce antibodies. Okay, there's a hint for that in the next part of the question. Okay. See here, part D talks about bacteria entering Jake's body, and Jake's body produces an antibody. If we go back to part C, producing antibodies is one of the defense mechanisms. So you can often read on in the question and get extra hints to help you out. Finally, the diagram shows one of the bacteria. In space below, draw a diagram of an antibody that Jake would produce to destroy the bacteria. Explain why you drew it that way. So 2 marks here to draw the right shape. We're going to want something that's going to fit onto the antigen. To fit onto the antigen. You've done this many times before. So it's going to be V or Y shaped. Okay, here's the mark scheme. A V shape, and the idea that it fits onto the antigens. Okay, you can use this idea of a lock and key, but you have to talk about the shape of the antibody. Part E. Sometime later, Jake gets the second infection of the same bacteria. So earlier he said it's the first time he got the bacteria. This is a later case of when he gets the same bacteria again. The graph shows the level of antibodies in Jake's blood. Okay. Number of antibodies in blood on the y-axis. Time after the first infection on the x-axis. So how many days after the first infection did Jake get the second infection? Well, here the number of antibodies suddenly skyrockets. So we would expect that to be about 60-65 days. Okay, you can see here, this is the first infection where the number of antibodies went up, and then he got better, dropped down. And then suddenly he gets ill again around here, and the number of antibodies increases very, very, very quickly. Okay, finally, a little bit of learning here. Part 2, name the type of cell that enables a much stronger response here, and that is a memory cell. Student looks at Jake's graph, he makes these conclusions. Just if you've forgotten, there's the graph again in the bottom corner. After the first infection, Jake was immune to the harmful bacteria. The doctor gave Jake some antibiotics on day 83. Evaluate the conclusions made by the student and explain the reasons for your choice. Okay, so you need to make a judgment on what they've said. So, on day 83, the number of antibodies starts to go down. Well, he's made 2 conclusions. Okay, and what we should have said is the first conclusion is correct. Jake is now immune to the harmful bacteria. and the second one is incorrect. So you can explain why each is correct or incorrect. First conclusion, okay, you can see how quickly antibodies were produced. Much faster rate of antibodies being produced. And the second conclusion is incorrect because nothing is said anything about antibiotics at all. Okay, the antibodies were made by Jake, but not antibiotics. Antibiotics are drugs that you take outside. Okay, and because Jake's got so many antibodies, keyword there, that you don't need to take antibiotics. Antibiotics are extra chemicals you take to support your immune system if it is weak or low. Okay,